Hi, my name is Martin Altenstedt, and with me today I have Tobias Ahnoff.
Hello.
We work as security experts at Omegapoint in Sweden, and we specialize in application security and identity.
We will focus on what you need to create a strong authorization control for your REST APIs in this presentation. We will show that what an authorization design and implementation can look like and what defense layers it needs to have.
And perhaps I should also say that this is the template that we use during security reviews of others from an application security perspective. Perimeter defense in the form of a firewall or other product that protects an application server is a classical security design approach. But in the face of a modern architecture that consists of several independent services, like the one to the right, it is simply not enough. A modern service layer typically has requirements to allow for integration with other external systems over the internet, and the number of clients is more extensive than before, and there are often requirements for single sign-on between clients. Previously, we could implement authorization control as a shared module in a monolithic system, but today we face an implementation in each of these services, maybe even spread across multiple teams. And our community has come up with concepts like zero trust and defense in depth to build a secure system under these conditions. And from the perspective of our service, we need 4 essential layers of validation. First, there is the incoming traffic. Is it actually a valid HTTP request, for example, if the service is an HTTP API? Second, is the request authenticated? Is it correct for the operation that it represents? And is the request authorized to perform the operation? But note that even if we implement these protection layers, we should not remove the firewall. It should only not be the single defense layer. We should think in terms of securing our system in multiple layers. But we will start with identifying all of the actors in our system in order to design a permission model for all clients properly.
Yes, but before we go there, what if I have the system to the left? Do I have to move to the right system architecture with an identity provider and microservices first in order to get a secure system?
Right, no, not at all. The concepts and designs that we talk about here today are very much valid for the system to the left as well. There is no contradiction. If you have a monolithic solution, all of these ideas will help you develop a secure system. And I should also perhaps say that an architecture that consists of several independent services, like the one to the right, is not inherently more secure compared to a monolithic system.
That's a good point. Yes, so we will look at the modeling of identity. And today we often use OAuth and OpenID Connect when we design and build secure APIs. They are flexible, often used together with the OpenID Connect on top of OAuth. We use them for different domains like e-commerce sites, online banking, healthcare, with high security demands and so. The concepts we will talk about are general and also applies for other protocols like SAML, or even for if you just have a local forms authentication, you still need to start with the modeling of identity. But there are of course differences between the protocols when you implement them. There's different solutions. In an OAuth context, we have users, which is just humans, clients, which is software, that is used to access data that holds access tokens. We have resources. Often these are REST APIs, so we refer to them as services, even though the spec says resources. And we have something called scopes and audiences. We will talk about them later on. In order to define our model, we start by drawing a picture with all different kind of users, the clients, and the services for our system. You should note that 3 of them involves a user, while the 4th does not, and it's just machine to machine. But regardless of which client we use, we still need a strong access control.
And perhaps we should say that these machine-to-machine integration clients are often forgotten. It is a very important aspect of the inventory to actually identify these clients as well.
Yes, especially in legacy systems where you might have a lot of integrations which you forgot about. They just are there and works until someone changes something.
Yes.
Yeah. So now it's time to do the modeling, and one way which we use is to draw arrows that shows which client that access a service and which users that access a client. So in our example, we can see that someone working in the warehouse has permission to use the inventory app to read orders, but not to create any. From that we can identify suitable audiences and claims by looking at the arrows. Where audiences are used to group services, and by that answer the question, is this ticket meant for me as a service? And scopes you can use to limit access to specific parts of a service or type of data. Often scopes are domain oriented, but they don't have to be. It's up to you how you will design that. But the scopes and audiences choices you make is important because they will limit how fine-grained the ticket or token can be in our system. If we have just one audience with the scopes we have identified here, then we cannot limit order read access to just the statistics API. Audience together with scopes must provide the granularity you need. Or you could have just one audience and more scopes. For example, we could have the scope on the form statistics.order.read and then order.order.read. And then we would provide the same granularity as if we had one audience for each API or service. And then identity provider can also provide a so-called consent UI, where the user can select which audience and scope combinations to grant for this specific authorization request or session. User consent is sometimes implicit. For example, when you log in to your banking application, then the client will get all the audiences and scopes needed to do its work. There is no choice, you just log in. But when you use social logins, you often see this screen and might not give access to email or profile and such. And also an interesting use case is that an administrator, if we look at the arrows above in this presentation, is that the administrator sometimes just need read permissions and could then choose not to get the right permissions when logging in from example a conference or from home.
Right, so this doesn't look too difficult. Is it as easy as doing an inventory and then drawing these arrows?
Well, In theory, it's so easy, but of course it could be very complex in some systems and in reality, of course, with a lot of arrows and maybe hard to understand all the clients you have and so on.
Right, but there are no technical difficulties. Is it enough to have? You can have non-technical people to join in the session where you create this map, right?
Yes. It's a domain design. It's not a technical difficulties. Yes.
Right. And I think that we should also note that the resulting map is an excellent piece of documentation of the system.
Yes, that's very important. It might be the first time you draw this map and sort of get the whole picture, maybe. So it's a very good documentation. And so by identifying audiences and scopes, we have what we need for our identity model regarding clients. But now let's look at the user.
Right, so identifying scopes and audiences, as we did in the previous slide, allows us to authorize the clients, and it remains now to authorize the actual users. So in authorizing the requests coming from Emma Smith in particular. Every request to every API includes a token that contains information about the user. Her identity, details about the authentication event, and what scopes and audiences that she has consented to. And based on this information in the token, we will move to a permission model in order to make authorization decisions in our domain logic. And these two concepts of authorizing clients using scopes and audiences and authorizing users based on identity, they work together. And a user that has an administrator account can still not create data if she uses a client that does not have right scopes. So for example, in this image, if Emma Smith has an elevator administrator account, and she uses the inventory iOS app that only has product read and order read scopes, she is never able through that client to create anything.
Yes, and now we will look at how we can implement this and build a strong defense in depth according to the principle of least privilege, which means that we need to minimize the permission set for each request. We will define a design pattern in 6 steps where we look at an incoming REST API request.
So in this picture, and where are we now in the system? This is within the API, right?
Yes, that is correct. Within each API or service.
Right. So each API will need to implement these steps for each request.
Yes. Yes. So if we look at step 1, we start with validating the incoming request, that it has the correct format. Typically is a HTTP request, has a reasonable size. Some products might be able to do a more in-depth analysis and react request that looks bad or suspicious. Note that this is something that you as a developer often do not think about, and is part of the infrastructure and operation. But this is an important layer of defense. We must have a secure, hardened web server with secure defaults facing the internet. Some frameworks ships with web servers that requires a reverse proxy in front of it. We should also use some sort of firewall product that will reject the majority of all those automated attacks that are constantly hitting us from the internet. Security is built in multiple layers, infrastructure and in our application code. So if we look at step 2, you need to validate that your ticket or access token is correct. For a REST API, this often is a JSON Web Token. You should use secure hardened frameworks which provide you with the functions you need to validate your ticket or token. This should be configuration, not custom implementation that you build. If you are reading the JSON Web Token specs, you should probably consider another framework. But of course, sometimes you don't have that luxury. And for a JSON Web Token, we need to verify that the cryptographic signature is correct, the issuer, that it's from the expected identity provider, the audience, that it's for you or for this service, the type of token also. We should only accept access tokens, not ID tokens or other tokens from the correct IDP. And of course the expiration time and not before. And if we use token binding, we need to verify that as well. And if any of these steps fails, then return 401 unauthorized. So now we know that we have a valid HTTP request with a valid ticket or token. But before we can do fine-grained access control, we need to go from authentication metadata represented as claims in our token to local permissions, which are understood and controlled by your domain.
Yes, so this is done in step 3, which is about transforming the information in the token to a local permission model that makes sense for your domain, the domain for the service. And this can be as simple as an in-memory lookup based on user identity or client ID, for example. Or it might be a database query or service call where we get roles or equivalent information based on user identity or organization. But the important part is that from this point on, the implementation will only work with the permission model, not with the token directly. And we think that this is a strong pattern that enables the domain logic to be independent of the token protocol details.
Yes, that's an important point. And if we look at step 4, validate permissions to perform the operation. So as soon as we have our object representing the current permission set, we want to decide if it's enough to perform the operation. We like to do this as early as possible without accessing business data or consuming system resources. If our access requirements are not met, we just return 403 forbidden. This decision is often based on scopes like product read, but other parameters might be used as well. For example, client ID or login method, etc. Some operations might require multi-factor authentication or re-authentication by the user. So now we know that the request is authorized to perform the operation, but we have one more thing to validate before we try to reach any business data.
That's right. And in step 5, the next thing is to validate that the data in the request is correct. For example, an ID value can be limited to a well-defined alphabet and not allowed to be an arbitrary string of unlimited size. And we return any request that is not correct with a 400 bad request error status code. And input validation limits the attack surface for an attacker that is trying to run injection attacks. And it is also an excellent opportunity to monitor those 400 status codes in order to detect ongoing attacks. And you can also use the fact that you are writing code in a strongly typed language like Java. If you can declare request parameters as something other than string, you typically limit the surface area for injection attacks. And also moving to a well-defined moving to well-defined domain primitives as early as possible is also a very secure pattern. For example, if it is impossible to create a domain object with malformed data, then injection attacks becomes much more difficult. So now that we know that the data in the request is correct, there is one validation step left.
Yes, the final step, step 6. We need to validate permission to access the actual data. Sometimes it is easy to decide if the user or client has permissions to access the requested data, like for an get product by ID endpoint. We could validate that the requested product ID is from a list of products to which the user has access to. Or another example is a list of patients which a doctor is assigned to. If we do not validate this, then we will have a common get by ID vulnerability that we often find when we do securities reviews. Here, an attacker using a valid ticket can just guess IDs and get data for all patients or products in the system. Note that making IDs hard to guess by, for example, using globally unique identifiers is not a solution to this direct reference problem, even if it makes the attack harder. Because you might also need to revoke access. And usually those identifiers are primary keys. And once you expose them, they can't be revoked. You need access control in order to revoke a direct reference like that. Sometimes it's hard to make these decisions based on the request and a fast, simple permission lookup. Like, for instance, in a search function. This might be the last thing we can do. We first need to run all the complex domain logic before we know which data will be accessed.
So these 6 steps might seem like a lot of work, but remember that the first 2 steps are configuration and not implementation. And the other steps are not complicated. They also lend themselves very nicely to unit testing. I should also say that we often see vulnerabilities in this pipeline when we review code and perform penetration testing. Vulnerabilities here are typically powerful vectors for an attacker, so please be extra careful and do write those unit tests. So our experience is that it can be a challenge to find an identity model that is the set of scopes, audiences, and token claims that is just right for your solution. It should not be too simple and not too complicated, and it should balance information we place in the centrally created token with local permissions. We find that it's often best to start simple with claims in the token that are limited to the user's identity. But we often add information in the token related to organization. But things like, for example, what patients a doctor is responsible for probably do not belong in a token. We also note that even if the permission model is local to a service domain, all services can share a centrally managed repository of rights and roles. And all of this are critical architectural decisions in any system, and the service implementations must also be secure. So please use the well-known third-party libraries for things related to protocols, like verifying that a JWT token is valid, and please write those unit tests for the API pipeline that we talked about in the previous slides. So to summarize, we think that you should create an identity model by drawing a map of your system. Do perform that inventory. You should know that it can be challenging to find a set of scopes and audiences that are balanced. We find that a well-defined domain model is an excellent start. Transform from the access token to a permission model as soon as possible in your API pipeline. Think about how you will administer and who owns the user permissions, and find a balance between claims in your token and local permissions.
Yes, so all the things we talked about can be derived from some of the common basic security design principles we listed here in this presentation. We should use them. They will guide you in the right direction. When we do security reviews, we normally will find more vulnerabilities in more complex systems. Of course, that is not a surprise. And it's not just because of the size of the system, where more functionality will give us a larger attack surface. A more important aspect is that it is hard to get the whole picture. Big complex systems are simply hard to understand and to manage over time. Many of the weaknesses we find are there because the team does not fully understand the system. For example, a team might not know which APIs are public or how a third-party integration integrates with a legacy system. You cannot secure what you don't understand. So when we do security reviews and penetration testing, we always start with a short meeting where the team, together with us, draws the system map and answer the basic questions like what kind of data does the system handle? Which data is important to protect and where is it stored? How can you access it? And how is it protected? Which integrations exist?
So according to our experience, any secure system can always be described by the teams according to these bullet points. But the reverse is unfortunately not true. If a team can describe a system, it is not necessarily safe. But the understanding of the system will give you the conditions you need in order to build a secure solution. It is never a guarantee. So it's essential to understand the most common types of attacks and how they all work in order to create strong layers of defense against them. Luckily, you do not have to figure this out yourself. OWASP collects information and knowledge about this and provides actionable information about it. And in our experience, the OWASP top 10 list is a very useful reference for many systems, not just web application. Cheat sheets and proactive controls are very actionable and will help us understand how common attacks work and create secure implementations. Right, so we're coming up on the 30 minutes mark, and we would just like to close out by thanking you for listening. And is there anything you would like to add, Tobias?
No, we have covered everything we planned, and we're looking forward to good questions and discussion afterwards.
Right. Thank you.
Thank you.